Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh to our sir. So my name is Muhammad Hazwan Ashrani and I am from group that needs to solve question 9, which is the equipment is mixing chamber. We will discuss further in how to solve problems regarding mixing chamber. So this is my group mate. There are 7 of us assigned to work together. I proceed to the next part. I would like to show the schematic diagram for mixing chamber that I draw by using PowerPoint. So as we can see, we have two different flows converging into a single mixing chamber, and then the effluent is considered as one flow, meaning that it acts as one product from the two reactions.
Let's talk about the function of the mixing chamber. This device is used to mix two streams of fluid into one, and on the meantime will cause temperature change, and the temperature alteration is highly dependent on the mass of the two streams in comparison to each other.
Since the system is a steady flow, energy in is equal to energy out. This is the overall energy balance for the mixing chamber. By neglecting kinetic and potential energy and noting the process is adiabatic with no work, and we have two entrants and one exit.
The most commonly known place where a mixing chamber is applied is in the shower. There will be a section where hot and cold water will meet, and we will produce the most suitable water temperature for to take our bath.
So for another application of mixing chamber in daily life is a gas mixing chamber, as you can see in the diagram. And there's a type of condition that needed for a mixing chamber to creating the homogeneous gases mixture. So first, flow range of the 300 milliliter per minute up to 10,000 milliliter per minute. Second, for creating homogeneous gases mixture from the percentage down to the ppm range. And third, available with a quarter or 6 millimeter connection. And lastly, pressure rating up to 20 bar.
Let's discuss about tutorial question. Firstly, draw the schematic diagram and write down all the conditions from the question. T1 is 15 degrees Celsius. P1, P2, and P3 are 150 kilopascal. Then, list down all the assumptions. Steady flow process, kinetic and potential energy changes are negligible, no work interaction, the device is adiabatic, and thus heat transfer is negligible. The first step is to determine the enthalpy of water and saturated water vapor. For water, from table A5, saturated temperature is 111.35 degrees Celsius at 150 kilopascal. Since the temperature of the water is lower than saturated temperature, it is compressed liquid. So the enthalpy can be found from table A4 at 15 degrees Celsius by taking the enthalpy of saturated liquid. For saturated water vapor, the temperature and enthalpy can be obtained from table A5 at 150 kilopascal.
Now, looking into the mass balance part, since this is a steady flow system, we can conclude that the total mass in is equal to total mass out. And the mass balance equation is as follows. For the energy balance part, total energy in is equal to total energy out, as is a steady flow system. Since net heat, net work done, net kinetic energy, and net potential energy is 0, therefore the energy balance equation could be written like this. Then, by cancelling the mass terms and substitute the appropriate enthalpy values in the equation, enthalpy at state 3 is obtained. From table A5, since the enthalpy at state 3 is greater than the enthalpy of liquid but smaller than the enthalpy of vapor at 150 kilopascal, the exit stream is saturated liquid vapor mixture. Hence, at the saturation pressure of 150 kilopascal, the exit stream temperature will be the saturation temperature of 111.35 degrees Celsius. And by using this formula, substitute appropriate enthalpy values obtained earlier from table A5, we can get the quality of the exit stream, which is 0.41.
So the conclusion for this mixing chamber in general is that it is used to mix two different liquids at different temperature in a different flow to create a new mixture at a different temperature and at a different composition. So it is widely used in industries, and it is also known to be used in reducing environmental pollution, where they combine two types of harmful gases to produce one unharmful gases to be released to the environment. So I think that's all from our group. Thank you very much.